what we've already been learning in our class and like what the students' prior knowledge would be. So students have already been working with fractions, and they have compared like fractions with the same numerator or same denominator. And they're also already familiar with linear representations of fractions, so they have used all of the materials on your table. So they have used the Fiesener rods, they've used the fraction strips, and they have seen the number line before too. And then our lesson objective is students will be able to compare relative sizes of fractions based on the numerator and denominator relationship for a given whole. And students will be able to use the strategy of linear representation to make such comparisons.
And it's going to build off of what they did, or what we all did in the last lesson. Same numerator, same denominator.
So we have a problem that we're going to start out with. Does anyone want to read it for me? Claire.
Jessica and Destiny are participating in a competition at Ben & Jerry's. The competition is to create the tallest soft serve swirl in order to win a certificate for a lifetime supply of ice cream. Jessica's swirl is 5.8 feet tall. Sorry, I don't know. And Destiny's swirl is 5/12 feet. Whose soft serve is taller?
So this is a problem that I think that we can all use what we've learned in a previous lesson to solve. So we're going to give you some time to pair up and work through this problem. You can use your sheet of paper, but make sure you're on this side of the sheet of paper with the number lines on it, if that's what you want to use, or you can use your fraction strips, or you can use another. We'll give you a few minutes to
I got 12 here.
12. What grade are these? Yeah, you don't have to.
Can I use like anything I want?
Yeah, paper.
Okay.
I'm going to have 5, not 8.
So I know that it's 5 out of 12, so it's going to be somewhere like here. These two. Because I know that 6 times 2 is 12. And I know that 1 times 2 is 2. And then 5/8, that's going to be somewhere over here. So, Jess is the 5/8.
Jessica? Yeah.
Okay, so Jess has more.
This one is Jessica,
Yeah.
this one's Destiny.
That's pretty tall.
Jess, you really killed it. You really killed it.
Did you guys use a similar strategy?
I took 5.
No, you held on. Yeah.
5.
It is a good it's pretty cool. Yes, you have mine. What else for you?
Yes. How would this look like?
Well, this would say 5/8. This would say 5/12. With a greater than. Oh, I'm sorry. With a greater than sign pointing to 5/8.
And then, so what is the difference between these two fractions of the 5 and 6?
This one's bigger. The pieces.
So I made the top one my 8, so one is 8/8, 1/2, 4 is half of 8, and then I divided them up so that there were 8 tick marks. Here's my 5/8 ice cream cone. So this would be 1/8, 2/8, 3/8, 4/8, 5/8. And then this one is 12/12, half is 6/12, and then I divided it up so there were 12 tick marks, there were 6 in between each one, and then I went 1, 2, 3, 4, 5, and I did a bad job drawing this ice cream cone. It's so true. So the top is cut.
I did it and I see that you like
I took my paper cut. So to them, each of the shapes is divided into that many sections. And then I colored in that many sections. Like one is 5 out of 8 sections. The other one is 5 out of 12 sections. So my 5 out of 8 is smaller than my 5 out of 12 is smaller. This makes sense. So we're in that.
let's look at this. What do you think about these two pieces? Their size. Are they the same size or different size?
They're the same.
Are the sizes in your drawing the same size in pieces?
No. Pretty similar. They're pretty close. Like a little. I mean,
This piece and this piece?
I think a tiny bit.
And what do you think? What did we learn about fractions? About the number, the size of each piece of fraction. Should they be the same or different? The same. So, do you see why this might not give you the right answer?
Kind of, but how do I do it? I don't know how to do it.
So, let's see. Who thought that Jessica had the taller ice cream? Just show me thumbs up. Thumbs up. Who thought that Destiny had the larger ice cream? So we all agree that Jessica has the larger ice cream. I'm wondering what different strategies we use. So I saw Madeline's group back there use one strategy. Madeline, could you tell us what you did?
Yeah, if you want me to explain. Okay, so we used our little number tiles back here. So we pulled out the 1 to show that this was 1 foot. And then we pulled out 5 12 pieces and then 5 8 pieces. And then we compared them in comparison to the 1. And we could tell that 5 8 pieces were bigger than 5 12 pieces whenever we compared them. So we also talked about how we noticed that the smaller denominator had smaller pieces, which we thought.
Can you give me a me too if you also used fraction strips? I see some groups who use fraction strips. Who used another strategy? I see this group here. Emma, could you tell us what kind of strategy you used?
Yeah, so I know that 1 can be written lots of different ways. And so for this problem, I decided to write it as 12 over 12 and 8 over 8, because those are the two different totals, you know? And then I knew that 1/2 for 12 out of 12 was 6 out of 12, and for 8 it was 4 out of 8. And then I knew that 5 out of 12 is a little less than 6, so I marked that for Destiny, and 5 out of 8 is a little more than 4, so I marked that for Jess and saw that she had more.
Interesting. So for 12 out of 12, what does that mean? What number is 12 out of 12?
That's 1.
And that is describing the whole foot that we have. So are there any other strategies the students used? Any other strategies? Olivia?
So we use fraction strips and the number line. Wow. So what we did is we repeated the 112 5 times and then marked them. We were done with that. And then we repeated the 8 5 times and marked them. We were done with that.
And which one was long?
5 8.
5, 8.
Oh, yes. Yes, 5 8.
And what did that tell you about the answer for this problem?
Jessica has more ice cream.
So we're now going to have
So we have another contender. Who would like to read us? Olivia, go for it.
Sydney got so excited when she heard about the competition, she decided to join too. Her soft serve swirl ended up being half a foot tall. Who is in first, second, and third place now?
Okay, so for this one, before you get started, we are going to do things a little bit differently. Can you all flip to this side of the paper, please? For the 3 blocks. Okay, so for each of these, you can see each one is labeled with a different tool that we are using. So the first one says Cuisinart rocks, then fraction strips, and number line. We're going to have 3 new contenders pop up. Sydney was one of them. For each new contender, you will be using a different tool. So you will pick one tool to do Sydney's problem, or to add Sydney's height first. Okay. We'll give you a few minutes to do that. Go ahead.
Oh my god. Wait, so we have to use one half?
Yeah, so for Sydney, you can choose to either do the number line, the Cubes neurons, or the fraction terms. And then there's going to be another contestant after that, and you'll have to use a different.
The white ones?
No.
I think we're gonna have to use white more
For now, yes. You're going to compare just Destiny, we just used, with the new contender. So now, that's Sydney. Yeah, and Destiny and
and I feel like I can really mess it up.
We're using one to compare all three.
Okay. You got it? Okay.
Well, this is the 1/2.
Yes.
Sydney.
Oh, number one. This is gonna be perfect. So,
Yeah. And did you use it using the fraction? Okay. Sorry.
And how did you learn that? How did you know?
That's all.
we might add
See, I did this originally, and then they said I had to use a different strategy. So now I'm not.
Like 12. So if this is our
Can you tell me your thinking for this?
Because this is 1 foot. This is what's 5/8 was Jessica. Yeah. 5/8. Yeah. And then 5/12, which was Destiny. And then 1/2.
So if this is our whole,
And then you can still see
1, 2, 3, 4, 5. So this is 5. This is half. So half is a little bigger than 5.
And then what about Jessica?
I couldn't find 8 different pieces of the same thing. It only fits in 6 red lines.
So how many times do you
I'm giving it
Give it up.
This is
So who has
the most. Are these a 12?
Jessica has the most?
What is going on here?
So we're trying to use neurons, but I'm tricky and do it the fraction.
Okay, but we're gonna have to use these neurons the same way.
You will.
So we're gonna need 24.
We have to.
No, we need 24.
Oh, this is Destiny. So Destiny has less.
Because we have to find a common denominator because we tried to make it 12, or we tried to make it 12.
1 foot. Then this is Sydney,
This is half.
she's half a foot. And then this is Jess, which is 5/8. So you can tell that Sydney already has less. And then you've got Destiny, who's got 5/12, and she has less than Jess. This is Destiny, Jess, Sydney. So then Jess has the most, Sydney has the second most, and Destiny has an 8.
So half is going to be,
that's half.
nice. Good job. And then, so
That's
5,
half?
yeah.
What is these two?
12. So then half, we have to do 5/8 next, so we need 15, right?
Something that's.
Wait.
There's no laws that make for that, or gonna make one of these. Does that make sense?
So even the red ones don't fit?
Yeah, so the red ones is 3. So that's
And then
third.
so that's 5/8.
That's a good question. I would see about changing the whole. Is there any way we can change the whole so you can do 8s and 12s?
Okay. The whole is 24.
Oh, I get it.
So ignore this because I got frustrated because never mind to do 12.
Frustrated with the Grease Mountain. Because
said they weren't. It's still Jessica.
Yes, we did.
I used fraction strips. And I have my one hole. And then I had 5/8 fractions, just the blue confused. And then I had like the purplish color, which was one. Cindy has 5, and then I had my 5/12. And I knew that
You can have pulse.
Oh, you're right. You're right. One really close friend. Lauren is also not. He is getting down his next year, and they're like, I'm taking one to his place. So he was like, very cool. I didn't know that. I heard that like this idea really I didn't. I don't think it's like really good. This is like embarrassing that has our time.
Oh boy.
Like the service that we do.
This is one.
Okay.
And so we needed to find a common denominator so we can compare our fractions, which is 24. It's this long one is 24, right? So to represent 5/8, which is the longest, we needed 5 pieces because we had 5 and then to get just leave, we needed 2 pieces because we had multiple times 2 equals 24. And then you need 12 total. So we just
Oh, no, we did
that's what we did.
Oh,
So this is
Oh yeah, I just did it.
Yeah, we did it together.
And Sydney, she had the best.
Denise was like, the competition's not over yet. The competition's not over yet.
oh, I didn't even know that.
So, here's the like peg on it, like having 2 fingers. Like these are 4 times a week. It's some like how I feel that was
You
just
use
that's
the
that I got only word 5 hours a week outside of that if we're not going to pay.
It's basically the same.
They need to like give you less hours.
Wait, I need to kind of yeah, because like I'm trying to like
Okay, so we want to start to see what you all are thinking about these for second and third in this competition. And we want to see representation from each strategy. So we're going to start with fraction strips. So raise your hand if you used fraction strips. Okay, so I'm going to ask Shelby if she would be willing to come up to the document and share her strategy with fraction strips. Just keep
Okay. So, I started out with 1 hole so I could keep track of how much was 1 hole. And then I had my 8s because that was the most from last time. So I put 5/8 on here. And then I knew that 4/8 was the same as 1/2. So I thought that would probably be next because that was close to 5/8. So I put my 1/2 there, which is the same as the 4/8. And then I had my 5/12 that I put underneath there, which was less than 1/2.
So I have a question because I'm a little bit confused. So what is the order of the fraction?
Okay, so the most is 5/8 and then 1/2 and then 5/12 is the least.
Okay. So I'm a little bit confused because when we were just comparing 5/8 and 5/12, right? We put 5/8, we said that was bigger than 5/12. And 8 is less than 12. So I would think that 1/2 would go before the 5/8 because the 2 is less than the 8. Why is the 1/2 in between the two?
Because the denominator is the number of pieces that the whole is split into. So the more pieces you have, the smaller the pieces are.
And then since one half is just split into two pieces and you have one of the pieces, it's in between the big 8s and the smaller 12s. And also, I know that 4 8s is 1/2 and 6 12s is 1/2 because 4 is half of 8 and 6 is half of 12. So 5 12s is less than 6 12s, but 5 8s is more than 4 8s.
Yeah, so that sounds a lot like the strategy Emma used with the number line for the earlier problems. And I see that you compared each of those to the 1/2 as a benchmark. Great job.
Now we're going to move on to another strategy. We're going to have somebody who used a number line come up. Can you raise your hand if you used a number line? Okay, there's quite a few. Sydney, can you go up and share your number line? Sure.
Okay, so first I marked my bar at 1/2 because my number was 1/2 and that was already on the line. And then Jessica had 5 8. So I knew I had to split the number line into 8s. So I split it into 4ths, which is really and then I split the 4ths into halves, making 8s. And then I counted 5 of those and marked Jessica's. And then Destiny had 5 12s. So then I split the number line into 12s and counted 5 of those and then marked hers.
So why did you break it up into 12s?
Because the bottom of 5 12s is 12, so I knew that there were 12 pieces of that.
So at the end, who ended up having the tallest ice cream cone?
Jessica.
Jessica? And how did you know to place them in that order on the number line? So who's first on the number line? Who has the least amount of, or who has the least tall ice cream cone?
Destiny.
And then who's in the middle?
Sydney.
And then who is the largest again?
Jessica.
Jessica. So can somebody tell me what they noticed between the two strategies we've seen so far, the number line and the fraction strips? Jess?
They both line them up next to each other so you can see the size. So you're comparing size instead of the number.
Yeah.
Yeah, so you see the bar on the city strategy and in Toby strategies. They're lined up horizontally based on which one is longer, which one's farther down the number line, tells you which one is taller.
Yeah, Stanley?
I also noticed that they both compared them to 1/2 because that's a number that they know and is easy and it's marked on the number line. So they were comparing the fraction tiles because 1/2 is an easy number that they know, and they were putting the tiles in to see what the difference was. And on this one, they just measured it based off of the middle, which they know is 1/2.
Thanks, Stanley.
Last, we're going to have Quinceanera. Can we have Clara come up and show everybody how she did? Look at this.
Does anyone else use Cuisinart?
Tried, it's not work.
Does anyone else have trouble with Cuisinart? Like, figured it out.
Why is it pieces towards pieces here?
Maybe so.
Cocoa butter.
It's the mini map.
Oh, there's more.
All right, friends. So my group was trying to use the Cuisenaire rods, and it was a little tricky because you had to find a piece of Cuisenaire rod that could represent one hole that worked for both 1/8, 5/8, 5/12, and 1/2. So we figured out that we needed to have the Cuisenaire rods that represent, so that they represent 24.
How did you know that? How did you know it's 24?
Well, because, shoot, this doesn't go to 24. Can I make this?
We can do the dot cam.
Yeah.
Okay,
let's do the dot.
yeah.
We're switching.
Okay. Thank you. Alright, so anyways, we wanted to make 24, so we took 2 of the 10s and 2 of the 2s, because altogether that makes 24.
And why'd you choose 24 again?
Well, as I was saying, with the 12 and the 8, we need one that you could divide into both those numbers into like a least common denominator. And so the least common denominator was 24. So then we started by representing 1/2, which would be 12. So we picked these, and they make half. And then we had to represent 5/8. And we,
Who's a half again?
was it half again?
Is it Sydney?
Sydney is, sorry. So then the next one was 5/8, and we figured out that if you divide 24 by 8, you get 3, so we picked these green ones that make 3. And we lined those up, so you get 5/8, 5 with green ones. And then the last one was 5/12, and we figured out if you divide 24 by 2, you get, or by 12, you get 2. So we use the pieces that represent 2, and we line those up. And so then we can see that 5/8 was the biggest, which is Jess. And 1/2 is the next biggest, which is Sydney. And then the smallest is 5/12, which is Destiny. Oh, sorry. Now you can see it.
Good job. Okay, so that was kind of a lot for me. Can anyone re-say what Claire said, what her strategy was?
She had to find a hole that was 24 units long. And she found that because she found the least common denominator for 5, 8, and 2. So that's how she found 24. And then I feel like if we had been able to use the online thing and it had been able to go to 24, it would have been really helpful because you could see the 24 individual things and see how they added up. And see how, with the least common denominator, 24 equal.
So it was easier to see all 24 at the same time. Because 24 is pretty big, right? But why is it, and this is technical, why is it helpful to have them all on the same denominator? Why is it good to have the same little size pieces that can fit into the other pieces of the fractal system?
Because then you can compare them and figure out which one's bigger and which one's smaller.
And that's not something you can do when all the parts are different sizes, right?
Okay, I'm gonna go ahead and stop us. Great job. Do you all want to do your own glow and grow?
I like a slow processor, so
It's fine.
other people go first.
If you want to do it at the end, we can do that too.
I think that maybe probably to work a little bit more on the Cuisenaire one, because I think that was a tricky one to cover in that fraction strip, and the number line is a lot easier for students to compare. But I think that organizational wise, it was helpful that we had like all the tools and that they were all linear representations.
I think going off of that, the reason we had the Cuisenaire rods is if we had more time to go over the Cuisenaire rods, that's the the strategy that gets most at least common denominator, like comparing different fractions. So like with the way Clara did it, and it'll be easier to see if we have the online tool, obviously, but I guess it's difficult to anticipate how complex it will be, or like how much the students would struggle with it before this.
And then we'll open it up and you guys can call on people.
I was just gonna say, well, I really like how you chose, like how you set up the problem so the kids were like constantly comparing, and that you made them use different resources, because I think a lot of times kids get like stuck in one and then they're like, what do I do? I was gonna say with the Cuisinart rods, like what like you all were saying, I think that's like something where number choice would like play in, because I feel like if the like least common denominator had been like 12, that might have been a lot easier to like visualize, if that makes sense, compared to like 24. But like honestly, that's not something I probably would have thought about when I was planning this lesson, so I guess it's just like a note to self for the future.
I thought you guys did a really good job of posing very intentional questions. Every question that I saw you guys ask seemed like it was pre-planned, and I don't know if it was, but it did a really good job of building on like our thought processes.
I also think you guys did a really good job of asking students who resource idea, especially with like the video labs, because like I was also confused and I was about to ask the question, but then I couldn't even ask. Like that was like a lot for me, like can anyone else re-voice what Clara just said, so I thought that was really helpful.
Cool. We're at 3:30, so I'll just say something quickly. I also thought you guys did a really good job with questions, especially the when you were talking about the denominators with the 1/2 and the 8 and the 12, and you had said like, oh, well, earlier we talked about how 8 was more because it was a bigger denominator. And then you got to talk about the size of the pieces and how many pieces there were. I thought that was pretty great. I don't know, I'm curious to hear what Dr. Leva says about it, but I'm wondering if I was teaching this with kids, if I would have multiple, like the rods and the fraction strips available at the same time, because it seems like the pacing was really different. So that's something to think about, and he'll probably have more to say about that. But okay, great job, both of our groups, and